Okay, so good day everyone. So today we will be discussing higher order homogeneous linear DE with constant coefficients. So we are now solving general solutions for higher order DE. It means when we say higher order, you have now derivatives more than one, no, as its order. Okay, so it means it contains second derivatives and higher than that. So let's start. Okay, why did we call it homogeneous linear DE? So actually the common term for this is a differential equation with constant coefficients. So as you can see here in our example, okay, these are your second order derivative. This is your first order derivative, and this is your dependent variable. Okay, so there are only constants as their coefficients. It means your A, B, and C are constants. As you can see, the differential equation is also linear because the, the dependent variable does not have those, what do you call that, characteristics, no, of a linear DE. And it is also homogeneous because the degree of each coefficient, which is A, B, and C, are the same. Okay. So with this, if we are given a higher order DE, so in this case, this is a second order DE. Why is it second order? Because the highest derivative is second derivative. So what we need to do is we will just convert this higher order DE into its characteristic equation. So how can we do that? What do we need to do is you exchange or you substitute your second derivative into r squared. Your first derivative, you substitute it into r, and your dependent variable, you substitute it with 0. Okay? So in that case, it will now become ar squared plus br plus c equals 0. Okay, and after that, what do we need to do is we will just get the roots. Okay, it means we need to determine the value of R1 and R2. So how can we do that? The best way, if we have a quadratic equation, so again, this is a quadratic equation. Our characteristic equation is a quadratic equation, so it means there are two roots. So to get the roots of a quadratic equation, in algebra, we are using the quadratic formula. But here, we will utilize our calculator to get the roots. So we will use your equation mode later on. Okay? Then after we get the roots, what do we do? Okay. We have three cases for that. Case 1. If the roots are real and distinct. When you say real, there is no imaginary number. It means I is not present. When you say distinct, the two roots are different from each other. It means they do not have the same value and or the same number. No, they are distinct. They are different. If they are distinct and real, so the general solution is y equals c1 e raised to r1x plus c2 e raised to r2x. So what do we need to do is we just copy this and exchange the two roots in the exponent. And after that, that is already the answer. Okay? You just get the roots, Input it on our general solution, and that is our answer. Let's try it on our examples. Determine the general solution of the DE. We have the second derivative of y minus 20y prime plus 99y. So again, what do we need to convert is we convert this one into our characteristic equation. The value of A is 1, the value of B is negative 20, and the value of C is 99. So to get the roots, we just need to use our calculator. Okay. We go to mode. Equation number 5. Okay, you press down, then quadratic equation. Okay, so since we already have values for A, B, and C, we just input it here on our calculator. Take note, the A, B, and C are your coefficients. 1, negative 20, and 99. So the roots are 11 and 9. So that's it. So it means our general solution is y equals C1. E raised to the first root is 11 plus C2. The second root is 9. That is our answer. Okay. Take note that the number of roots corresponds to the number of constants present. So it means if you have 2 roots, you also have 2 constants. Okay? Okay, our next example, we have 2y double prime minus 4y prime minus 6y equals 0. So what do we need to do is we convert this one into our characteristic equation. This would be 2r squared minus 4r minus 6 equals 0. The value of A is 2, the value of B is negative 4, and the value of C is negative 6. So what would be the value of the 2 roots? Okay, so input your A, that is 2, negative 4, and negative 6. So the value of the 2 roots are 3 and negative 1. So it means our answer is y equals C1 e raised to 3x plus C2 e raised to negative 1x. That is our answer. Sir, ang question, what if sir mag-exchange, no? Or nauna ang negative 1? It is the same. Example, your answer is y equals C1 e raised to negative x plus C2 e raised to 3x. That is the same because we are only using subscripts for the constant to make them distinct with each other. So it means it is the same. Okay? As long as you have that two roots. Okay. Next, our next case is case number 2. If R1 and R2 are real and equal. When you say real, again, there is no imaginary number, there is no I. Equal means the two roots are the same. Okay? So if the two roots are the same, if R1 and R2 are the same, take note, we put R1 here, and when we put R2, since it is the same as R1, we introduce X. Okay, so it means every time there is a repeating root, you introduce X. Okay? So let's try. Determine the general solution of the DE. Again, We convert this one into our characteristic equation, 3r squared plus 30r plus 75 equals 0. The value of A is 3, the value of B is 30, and the value of C is 75. What would be the value of the two roots? Take note, okay? Once we input it on our calculator, 3, 30, and 75, take note, our roots are -5. Okay, so it means it only shows one root. When the calculator only shows one root, but we need two roots, it means the roots are the same. Okay? So don't be confused, ha? Base isa lang ka-root ang ibutang ninyo. Okay? Take note, if naka-squared, what is the number of order that is equal to the number of roots? And the number of roots that is equal to the number of constants in the answer. So take note, if your order is 2, your roots must also be 2. Okay. So our general solution is y equals c1 e raised to -5x plus c2. Okay, take note, once we have repeated a root, we introduce x. That is now e raised to -5x. And that is our answer. Okay, next. Determine the general solution. So again, convert this one into our characteristic equation. That would be r squared minus 26r plus 169 equals 0. Okay? So, it means the value of A is 1, the value of B is -26, and the value of C is 169. So what would be our two roots? 1, -26, and 169. So that is 13. Okay. It only shows one root, so it means the root is the same. 13, 13. So it means y is equal to c1 e raised to 13x plus c2x e raised to 13x. And that is our answer. Next. The next case is case number 3. What if the two roots are complex or imaginary? It means there is a real part, no? Your alpha represents the real part of the root, and your beta represents the imaginary part. So it means the beta is the number with an I. So what you need to do, take note that if you have complex numbers as your root, they are always in partners. So it means it is always alpha plus beta I and alpha minus beta I. So after you determine alpha and beta, no, the general solution is e. Take note, e raised to alpha x. So this is where we put the alpha. Multiply to c1 cosine beta x. This is where we put beta. You just copy all the equation and you exchange this, okay, with the value that you have determined from your roots. And that's it. Let's try our example. Determine the general solution of the DE. So again, characteristic equation r squared minus 4r plus 13 equals 0. The value of A is 1. The value of B is -4. And the value of C is 13. Is 1, -4, and 13. So our roots are 2 plus 3i and 2 minus 3i. Okay, so it means the roots 1 and 2 are 2 plus minus 3i. The value of alpha. What is the value of alpha? That is the real part, 2. And the value of beta is the imaginary part, 3. Do not include the I. Okay? And also take note, beta is always positive. Do not include the sign. So our answer is y equals e raised to alpha x c1 cosine beta x plus c2 sine beta x. That is our answer. Okay? That's it. That is how you solve your higher order DE. Okay. Next example. Determine the general solution of the DE. Okay. So you convert this one into your characteristic equation. You have 2r squared plus 26r plus 169 equals 0. It's the value of A is 2, the value of B is 26, and the value of C is 169. So what would be the roots? 2, 26, 169. Okay, that is negative 13 over 2 plus 13 over 2i. Okay. Negative 13 over 2 plus 13 over 2i and negative 13 over 2 minus 13 over 2i. So the roots 1 and 2 are negative 13 over 2 plus minus 13 over 2i. So the value of alpha is negative 13 over 2 and the value of beta is 13 over 2. Then our answer is y e raised to alpha x c1 cosine beta x plus c2 sine beta x. And that is our final answer. Okay. And that is it. No? We have only 3 cases for that. So we will just solve additional examples regarding higher order. Okay. What if we have this? No? We have r squared plus 25 only equals 0. So it means the value of a is 1, okay, because that is the coefficient of the squared variable. The value of b is, there is no r in the equation, so it means the value of b is 0. And the value of c is 25. So with that, what would be our root? 1, 0, 25. So our roots are 5i and negative 5i. So roots 1 and 2 are positive negative 5i. What would be the value of alpha? There is no real part in this complex number. So it means the alpha is 0 and beta is 5. So our answer is y equals e raised to 0x c1 cosine beta x plus c2 sine beta x. But again, e raised to 0 is 1. So it means y equals c1 cosine 5x plus c2 sine 5x. That is our answer. Next example. Okay, what if we have D is higher than second order? So this is now a third order DE. So if you convert a third order DE into its characteristic equation, So the third order would now become r cubed minus r squared minus 14r plus 24 equals 0. So this would be now A, B, C, and D because A represents the coefficient of r cubed, B represents the coefficient of r squared, C represents the coefficient of r, and D represents the constant. So that would be 1, -1, -14, and 24. So since this is now third order, so we also have 3 roots. Take note of that. Okay, so if we have 3 roots, input A, B, C, and D. Okay, I'm sorry. But our equation mode is quadratic. This is now cubic. So we go again to mode equation, okay, down, cubic. Take note that only Canon calculators can get the roots up to the quartic degree, or it means up to the fourth degree. Okay? Okay. So we go to cubic. Input 1, -1, -14, 24. So the value of R1 is 3, 2, and -4. So that is 3, 2, -4. So our answer is y equals C1 e raised to 3x, C2 e raised to 2x, C3 e raised to -4x. That is our answer. Let's have the next example. Okay, we have this one. So again, convert it into your characteristic equation. The value of A is 1. The value of B is -42. The value of C is 588. And the value of D is -2,744. So what would be the 3 roots? Using our calculator, 1, -42, 588, -2744. So that is 14. Okay, it only shows 1 root. So if it only shows 1 root, it means all the 3 roots are equal. So our answer is, this is a little bit of case 2, okay, real and equal. C1 e raised to 14x plus C2. Again, the root repeats. It means we introduce x plus C3. The root again repeats. So we introduce not x, because it will be the same with this equation on our previous equation. We now include x squared. So it means it is in succession. If we have another root that is the same, we multiply x cubed and so on. That is our final answer. Okay, next. We have this one. Get the characteristic equation. That would be r cubed plus 10r squared plus 12r minus 72 equals 0. So the value of A is 1. The value of B is 10. The value of C is 12. And the value of D is -72. What would be the value of the 3 roots? 1, 10, 12, -72, 2, and -6. Okay, sir, why is it only 2 roots? It means one of the roots repeats. Okay, how can we determine which of the root repeats? So to determine which of the root repeats, I have a tip, no? on how to determine that without using synthetic division or long division, what you need to do is take note of the constant in our characteristic equation. So the constant is negative 72. What you need to do is you transpose it to the other side of the equation or change lang ang sign. Take note. Negative 72 would now be 72. Take note that if you multiply the three roots, it must result into 72. Okay? So, dapat, if I multiply the three roots, 2 times negative 6 times, I don't know what the third root is, that must be equal to 72. So what do we need to do is shift solve. Now, shift solve. So the other root is negative 6. So that's it. But again, you can also use your mental skills, no, to determine what is the other root by simply multiplying and dividing. So it means our answer is y equals c1 e raised to 2x, that is the first root, plus c2 e raised to negative 6x, that is the second root, plus c3, again, the root repeats, we introduce x. That is our answer. Next. Okay, we have this one. So again, we convert it into your characteristic equation. Okay, that is 300 only. A is 1, B is 6, C is negative 47, and D is 300. What would be the value of the three roots? Mode 5 down and 2. That is 1, 6, negative 47, and 300. So that is negative 12, 3 plus 4i, 3 minus 4i. Okay, again, negative 12, 3 plus 4i, 3 minus 4i. And these two roots would now combine into R2 and R3. This would now be 3 plus minus 4i. So our general solution is y equals, we use first the negative 12, that is c1 e raised to negative 12x plus. So this is now imaginary or complex. Our alpha is 3, our beta is 4. So it means e raised to alpha x c2, no? Because we already use c1, cosine beta x plus c3 sine beta x. So we check. We have three constants. So this general solution is our final answer. Next. Okay, we have this one. Okay. So r cubed plus 2r squared plus 4r plus 8 equals 0. So the value of a is 1, b is 2, c is 4, d is 8. What are the three roots? 1, 2, 4, 8. That is negative 2, 2i, negative 2i. So negative 2, 2i, negative 2i. So once nga may imaginary, combine it, 2 and 3. This would now become plus minus 2i. The value of alpha, there's no real number. The value of beta, 2. So it means our answer is C1, e raised to negative 2x plus e raised to 0x, C2 cosine beta x plus C3 sine beta x. But again, this is 1. So our final answer is C1 e raised to negative 2x plus C2 cosine 2x plus C3 sine 2x. That is our general solution. Okay. Next. Okay. Next. Okay, the characteristic equation is r cubed equals 0. What is the value of A? That is 1. Value of B? There's no r squared, so 0. Value of C? Wala sang r, 0. Value of D? There's no constant, 0. What are the three roots? 1, 0, 0, 0. 0. So the three roots are all 0. So this is a repeating root. Answer for general solution is y, c1 e raised to 0x plus c2. Okay, it repeats, so include x plus c3. Again, it repeats, include x squared. But e raised to 0 is 1, so our final answer is c1 plus c2x plus c3x squared. That is our answer. Next example. Okay, so we have this one. R cubed plus 6r squared equals 0. So A is 1, B is 6, C is 0, and D is 0. So we have three roots. 1, 6, 0, 0. Negative 6 and 0. So negative 6 and 0. There are only two roots displayed. No? How can we determine the last root nga nag-repeat? Because once nga two roots lang ang gin-display, then we need three roots. There is one root that is repeating. And we don't know if it is negative 6 or 0. So what do we need to do? We cannot use our tip anymore na ang constant. Divide lang sa multiplied ng roots because any number multiplied to 0 is 0. So what we need to do is extract this equation into or divide the equation, okay, with r. Or rather, factor out na lang ang r. No? Okay, so it means you have r squared. So once that you can factor out r squared, it means there are two zeros. If r lang ang ma-factor out, it means there's only one zero. So it means there are two zeros in our, what do you call that, roots. So y is equal to c1, e raised to negative 6x plus c2, e raised to 0x plus c3, again, repeats, x, e raised to 0x. But this is 1. So y equals c1, e raised to negative 6x plus c2 plus c3x. That is our final answer. Next. So next example, last example, okay? We have r cubed minus 4r squared plus 4r equals 0. I mean, the value of A is 1, B is negative 4, C is 4, D is 0. Okay, 1, negative 4, 4, 0. 2 and 0. Okay, let's check. We can factor out in the characteristic equation only r. So kung r lang ang ma-factor out, it means there is only one 0. So it means the other root is 2. So y equals c1 e raised to 2x plus c2 e raised to 0x plus c3, again, the 2 repeats. So x e raised to 2x. But e raised to 0x is 1. So y equals c1 e raised to 2x plus c2 plus c3 x e raised to 2x. That is our final answer. So thank you so much.